So here's a distance time graph question. Let's just read the question to start with. Ben drove 60 kilometres, and I can see that on the graph, from his home to Liverpool. So 0 kilometres is his home. And then 60 kilometres is Liverpool. He stopped and visited his friend Tim on the way. Now you can see if he's stopped, he's not getting any further away or further closer to home. So that's this bit here. Work out Ben's speed for the first part of his journey. So for this part, I'm literally just going to look at the time and we're going to look at the do stop talking triangle. So for the first part of his journey, let's do this bit in green. That's this bit here. And it's between 1 and 2, so that's 1 hour. So he's gone, time is 1 hour, and he's gone 30 kilometres, so distance is 30 kilometres. So when I do my do, stop, talking triangle, and I want to find out the speed, I need to do distance divided by time because I'm covering up the speed there. So that's going to be 30 kilometres divided by 1 hour, which is 30 kilometres per hour. The next question says, how long did Ben visit Tim? So that, like I said, was the horizontal part where the distance is getting no further or no shorter. So it's between here, which is at 2 o'clock, and here, which would be 3:30 or 15:30. So between there is an hour and a half. Or 1.5 hours. Okay, so the last bit, work out the Ben's speed for the last part of his journey. Now I'm going to look at this slightly differently this time. So you can use the do stop talking triangle or you can use gradient. So I'm going to show you how to use gradient here. So gradient always represents the rate of change. So that's the rate of change of the distance and time. So it's distance divided by time, which happens to be the speed. So the gradient here. Now gradient, we always look for 1 across, how many up. So let's just look at this at the moment. So if I look at, so we're looking at the last part of his journey. So let's just highlight that. That's this bit here. And I'm going to look at how far we've gone across. So we've gone from 3:30 to 5. So that's 1.5 hours across. I'm going to put the units in there because you'll see why in a second. And then we've gone, so that's 1.5 across. And we've gone from 30 to 60, so that's 30 up, so that's 30 kilometres up. Now we know with gradient we always want 1 across, so I'm going to get 1 here. And I don't want 1 hour, I just want 1 across. So I'm actually dividing by 1.5 hours. On this side. And divide by 1.5 hours on this side. So 30 divided by 1.5, I'm just going to use my calculator to do that, is 20. But we're also doing kilometres divided by hours, and that's where the unit's coming from, and that's how I know it's speed. So my answer here would be 20 kilometres per hour. So the lesson there is that to find the speed on a distance time graph, you can either use your do stop talking triangle or you can use gradient and figure out the gradient. So here's another distance time graph, but it's slightly different. Let's have a look. Laura goes for a cycle from her house to the post office 4 kilometres away. So the post office is there. And 0 would be her house. How long did it take Laura to cycle to the post office? So she's leaving her house and she's going to the post office. And that's gone from that point there. If you look at the graph, it's going from 11 to 11:10. So in the middle would be 11:05. And draw on your graph, draw down. So 11:05 to 11:20, that would be 15 minutes. Work out Laura's speed cycling to the post office. Again, do stop talking. So to the post office. So the speed I want to know. The distance is 4 kilometres. And the time was 15 minutes. I'm straight away going to change that to, well, actually I'm going to show you 2 different ways. So you could do 15 minutes at the moment. Now if we were doing this like a ratio, if you think there's 4 kilometres, takes 15 minutes. We want 60 minutes because we want 1 hour, because it's miles per hour. So I need to times by 4 there. So it would be 16 kilometres per hour. Obviously you could have done it the do stop talking way and changed that to 0.25 straight away. And you want the speed, so it's distance divided by time. So 4 kilometres divided by 0.25 hours, you'd have ended up with 16 kilometres per hour. Again, so either way, that doesn't matter. Next, how long did Laura spend at the post office? So that's the bit where she's not moving. She's not getting closer or further away. So that's this bit here. Again, draw your lines down. So we're going from 11:20 to 11:40, so that's 20 minutes. And then work out Laura's speed cycling back. So again, you can use the ratio method, which was this one here. You can use do stop talking, or you can use gradient. I'm going to use gradient here. So just to recap of what we were doing. So we've got, if I use gradient, we're always looking at across and up. So here, and the one thing I do want you to notice, it's going down because it's going back towards home. It's not going further away home, it's going back towards home. But that's not going to affect the speed, even though we would normally put negative at the end. I'm just going to change it back to positive speed. So here we're going, how many across? Well, it's from 11:40 to 12. So that's 20 minutes across. Now, that's 20 minutes. So I'm going to change that to 1/3 of an hour. 20 out of 60 simplifies to 1/3. So that's 1/3 of an hour across. And we're going from 4 to 0. So that's 4 down. I'm going to keep the negative in just for mathematical purposes at the moment. I always need 1 across. So I'm actually going to times by 3 here to get it back up to 1. So if I times by 3, I get 1 hour is -12, and divide by that hour. And I get 1. I forgot to put my kilometres on, so kilometre there, so it's -12 kilometres per hour, but obviously we don't need the minus, so it's just going to be 12 kilometres per hour. So again, there's 3 different ways of finding speed on a distant time graph. Ratio, which is this one, do stop talking triangle, or the gradient. So you can always do one way and then figure out the other, just to check your answer.